Hello everybody, so now we're going to do the Pascal triangles and the powers of binomials, and I'm going to show you how they connect to each other. So powers of binomials actually. So many of you know that when I have a plus b all squared, this is going to be equal to a squared plus 2ab plus b squared, right? Now, why? A plus b squared is like doing a plus b times a plus b, right? Then you apply the distributive property, and you get a times a, which is a squared, a times b, which is ab, plus b times a, which is ba, times b times b, which is b squared, right? This is the same as saying a squared plus 2ab, right? ab times ba is 2ab plus b squared. So that's how we get it, or derive it. So you should know this. It's pretty basic. Now, we're going to do something called the Pascal triangle, okay? It might take you some time to get used to it, but once you get it, it's pretty simple, okay? The Pascal triangle, you'll always start with a 1, okay? And every time you go down, it's going to have one more number than the previous one, okay? For instance, in here I have one term, right? Just the 1. In the second one, I'm going to have 2 terms. And then the third one, I'm going to have 3 terms. And then 4 terms. And then 5 terms. And then 6 terms, etc., etc., etc. Okay, forming a triangular number, but it's infinite. So the Pascal triangle starts with a 1, okay, and in every line or row, however you want to call it, you always start with a 1 and end with a 1. So the second row will be 1 1 because you start with a 1 and end with a 1. The third row is you're gonna again start with 1, and then you're gonna add the terms that you have right here in the previous row. So 1 plus 1, right? 1 plus 1 is 2. And then you end with 1 because you need 3 terms. In the fourth row, you need 4 terms, okay? So again, I start with a 1, then I add this 2 guys, so 1 plus 2, which is 3. Then I add 2 plus 1, which is 3 again. And I end with a 1, right? Then, again, I start with a 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Right? And I end with a 1. See how in here I have 1, 2, 3, 4, 5. In here 1, 2, 3, 4. Here 1, 2, 3. Here 1, 2. Here 1. Because every time you're adding one term, right? Or one number. So remember, I'm adding these 2 guys to get to this one. Adding these 2 guys to get to this one. Adding these 2 guys to get to this one, and I end with a 1 and start with a 1 always. This is a Pascal triangle. Now, you may notice from this automatically that here we have the counting numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you will always have them. Now, what do you notice in here? In this row, I'm actually going to do one more row so you can start to see the pattern in that diagonal. 1, 4 plus 1 is 5. Try to do it on your own. Pause the video if you need to. 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and we end with a 1. What do you see in common with these numbers right here? Try to think about it. Okay. What you should have noticed is that they are triangular numbers. What do I mean by triangular numbers? I mean, 1. It's with the little dots, you can complete a triangle. So 3, 2, 1, like the Pascal triangle. 3, 4, 1, 2, 3, 1, 2. It's getting smaller each row, right? So here we have 1, 3, 6, 10, which is exactly what we have here. And they will be consistent all the way through. So that's pretty amazing as well, I would say, right? However, why did we do the triangle? And how can we connect it to this operation? What if I tell you to do a plus b to the third power if you don't know how to do it, if you don't have it memorized? Well, you could use the formula we're going to review in a second, or you could use the Pascal's triangle. We're going to call each term a number, okay? So we're going to start with n equals 0, okay? And then we'll go with that. N equals 1, n equals 2, n equals 3, n equals 4, n equals 5, etc. Okay? And what this 0, 1, 2, 3, 4, 5 means is the power that the a plus b is going to. So if I want to see the square, then I'm going to take this row because it is n equals 2. Now this is row 1, this is row 2, etc. So you're just going to subtract 1 to get the n, okay? For instance, let's do this one. Let's do it as an example. So I can figure out how much is a plus b squared. I'm going to take these three numbers I have, 1, 2, and 1, okay? And what I'm going to do is I'm going to name each coefficient a and b. So ab plus ab plus ab, right? So I took 1, 2, 1, and I just gave every number, ab, 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 right? Now, what I'm going to do is that the first a in the equation, the first one, I'm going to give it a 2. Why? Because we're doing n equals 2. So this goes right here. B is going to start at 0. B needs to end with what A starts with. So it shall end with 2. And actually, B goes 0, 1, 2. Always. It's like counting. And A does the opposite. It goes down. So 2, 1, 0. 2, 1, 0. And if you simplify it, you'll get a plus b squared. Right? You see? This becomes a squared because it's 1. A squared and b to the 0 power is 1. Plus 2. A to the first power is a. B to the first power is b. Plus 1. This is 1, so it just cancels with 1. 1 times b squared is b squared. And we get the same we got here. Now, it is now easy to find each new line of the triangle using the coefficient from row, whatever n you want. So, it's amazing, the Pascal's triangle. Let's do one more example with n equals 4. So when I'm doing n equals 4, it's going to be a plus b squared. It's the fifth row. And if it's the fifth row, I'm going to take out 1 because we're starting with n equals 0, right? Because that's a power. And we know it's 4 automatically, just by knowing the row. Great, guys. So with n equals 4, I'm going to find how much is a plus b to the 4th power. Again, I'm going to take these numbers in the 5th row, or in the n equals 4 row. So we have 1, 4, 6, 4, and 1. I want you to pause the video and do it on your own, okay? If you still don't feel confident, keep on watching what I'm going to do. So again, I'm going to give AB to each number. AB plus AB plus AB. You're always going to add it and put AB. Always. And again, A will start with the N, which is equal to 4 in this case because we want to find the 4th power. And it's going to end in 0. So 4, 3, 2, 1, 0. It's like counting 0, 1, 2, 3, 4. Always. B is going to do the opposite. So it's going to start with 0 and end with 4. So 0, 1, 2, 3. And now you simplify it to know how much is A plus B to the 4th power, right? Equals A to the 4th power plus 4A cubed B plus 6A squared B squared plus 4AB cubed plus B to the 4th power. And this is the answer. We're going to do one last example with n equals 5. Right here. N equals 5. So, A plus B. Let's try to do it on your own. I'm going to write the numbers, and once I do it, pause the video and try to do it on your own. So, 1, 5, 10, 10, 5, 1 are the numbers, right? And I'm going to give A, B to each one. A, B, A, B, A, B, A, B, A, B. And because it's to the 5th power, A is going to start with 5, and it's always going to end with 0. And then go progressively. 5, 4, 3, 2, 1, 0. On the other hand, B is going to start with 0 here. Then 0, 1, 2, 3, 4, 5. There we go. So then we get A to the 5th power plus 5 A to the 4th times B plus 10 A cubed B squared plus 10 A squared B cubed plus 5A B to the 4th power plus B to the 5th power. And this is equal to A plus B to the 5th power. And notice how we have 1, 2, 3, 4, 5, 6 terms, which is always one more than what we're getting the power to. And that is basically it. Now, you may be wondering, what if they ask me a much bigger number and I don't want to do the whole Pascal's triangle, right? Then I can use the binomial theorem. Teachers tend to let you use your calculator for this one, okay? So, get out your calculator, and I'm going to show you exactly in the TI-84 plus CE, or TI-84, how to do it. But first, I'm going to show you the basics. The sign in the calculator is NCR. And this NCR is equal to n factorial over r factorial n minus 3, like this. Okay? Now, n is the power. R is 1 less than the position. So position minus 1. Okay? So for example, we're gonna do an example in a second, okay? But first, let's do a table. We're gonna do a table, okay? Something like this. And then we're gonna do 1, 4, 6, 4, and 1. Now, where did I get these numbers from? I got it from the Pascal's triangle. Here, 1, 4, 6, 4, 1. And the n equals 4. Row, right? Which is the fifth row. I got it 1, 4, 6, 4, 1, right? And I'm actually gonna copy the Pascal's triangle so we can have it by our side. Copy, and we're gonna paste it in the side over here. Okay, great. Okay, so I'm using this for 1, 4, 6, 4, 1 in the Pascal's triangle. And what I'm going to do, so this is Pascal's triangle. And we're gonna do in this row the NCR formula in our calculators. So using the Pascal's triangle. Remember, n is the power. In this case, we want the power of 4. To the 4th power, right? So in Pascal's triangle, you get 1. But to get it in your calculator, you're going to put 4, because that's, again, the power. C, 0. And that is going to be the first position over here, right? Because it's position minus 1, which in this case is 0. Then to get the second position, it's going to be the same power plus 1. Then same power plus 1. Same power plus 1. Same power plus 1. Right? So the fourth position is in the Pascal's triangle, 4 plus 1. So it's this one, 1. And go ahead and do it in your calculator. How? In your calculator, you're going to press on, well, turn it on, and then put math. The keyword says math. Then you're going to put the right. You're going to put the key that looks like this with the arrows, right? Like this. This one is down, this one is up, this one is to the right, and this one is to the left. You're going to press this one to the right. You're going to press it 1, 2, 3 times. Press it 3 times. And then you're going to press the 3 or where it says NCR. Okay? And then plug in the values. So for the first one, plug 4 and 0. You'll get 1. Then plug in 4C1, you'll get 4. Then plug in 4C2, you'll get 6. Then you get 4. And then you get 1. So this is how to do it without doing the whole Pascal's triangle. Knowing this, you can do the AB thing. So AB plus AB plus AB plus AB plus AB, right? And you're gonna do the here what we have learned. Pause the video and try to do it by your own, because we did the same example here, right? We said that we start with the powers, which is 4, and B starts with 0, and then 3, 2, 1, 0. And B goes 0, 1, 2, 3, 4, right? That's what we said. So, like this will give us a to the 4th power plus 4a to the 3rd, b plus 6a squared, b squared plus 4ab cubed plus b to the 4th power. Let's check it with the previous one to see if we got the same answer. this one. And check it out. We have the exact same answer. See? Boom, 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 boom. Same answer. And that's how you do it with the formula. And that's what we learned with the Pascal's triangle and the squares and the powers. The binomial theorem, the Pascal's triangle and the powers of binomials, etc. I hope you like this video and learned a lot. See you in the next one.